welcome back friends. In this week of the public transportation lecture series, we will introduce you to the various critical concepts or operational concepts that are used in public transportation. You have so far learnt about how to measure the performance of public transportation systems. We have looked at IPT, rail and bus. Now, let us look at some of the operational concepts in public transportation systems. Some of this may be a little bit advanced. So, I request all of you to kindly pay a little bit more of attention to these lectures. What we are essentially going to talk about are the operational concepts of capacity, speed and reliability, how to measure them, how these affects travel time, travel environment and station stop characteristics, also how these all of these aspects are interconnected and how they affect each other, and give you some illustrative impacts of these on the of these operating keys on the operational aspects, and that will tell you how each of them are related to each other. So, when we talk about capacity of transit services, the first capacity that we want to know is person capacity, right, T subscript CP. So, person capacity is something that we are always wanting to know of any public transportation system, of any transit route or a facility. So, how is it defined? It is defined as a maximum number of people that can be carried past a given location during a given time period under specific operating conditions without unreasonable delay, hazard or restriction, and with reasonable certainty. So, it is essentially the maximum number of people that can be transported or carried using your public transportation system under certain provisions, right. These provisions have to be met. So, it is carried past a given location. So, if you want to know the capacity of your line, you have to pick a location. So, at a given location reflects that the capacity reflects the number of people that can be transported past a given point, typically the maximum load point of the segment. So, you just pick a segment and say that n number of people have crossed this segment on your public transportation system, and that gives you the person capacity. It is under specified operating conditions. So, these operating conditions should be normal, should not be any unusual day where there is unusual capacity or unusual stress on the public transportation systems, without unreasonable delay, hazard or restrictions. So, the conditions where the public transportation is operating should be normal as well. There should not be any excessive delay, rather than just the normal delay that you see on everyday operations, meaning that there should not be a huge accident or anything that is causing a larger delay to the system, and with reasonable certainty, saying that this is the capacity that can be carried day after day, right. This is some kind of certainty that we are saying that this is the person capacity that can be carried day after day. It is not just one day in which this much maximum number of persons can be carried. So, all of this put together gives you an understanding of person capacity of a public transportation system. So, when we look at what are all the different factors that influences person capacity, there are a whole host of factors starting from land use, characteristics, stop accessibility, but more importantly, if you look at the ones that are in bold, because those are factors that will not only affect person capacity, but it also influence speed and reliability of the system. So, maybe these are the ones that you should be focusing on. For example, stop spacing. So, if the stops are too closely spaced with each other, that means there may be a possibility of more number of people accessing the system, and hence the person capacity of the public transportation system may be increasing. Whereas, if the stops are spaced too far from each other, then maybe people will not be willing to walk up to the stop or take a auto rickshaw to the stop. They may be just willing to use their private vehicle and not use public transportation at all. So, stop spacing plays an important role. Passenger demand variability, do all types of passengers want to use it, or is it just the office going public, or is it just the captive passengers who wants to use it? will tell you what dwell time is, how long a bus sits at a bus stop to collect passengers is dwell time. So, the larger the dwell time, the more the number of people that it can serve. However, the larger the dwell time, it may be missing out on other passengers in other stops. So, there has to be some kind of optimization of that. Guideway type, if it is a exclusive guideway that the public transportation system is working on, then its person capacity increases. If there are too many traffic signals, then the capacity decreases, and so on and so forth. So, there are, you will see it is a very complex method to calculate or to estimate the person capacity of a transit route. But if you were to do so, and many public transportation systems have done it, you have to take into consideration all different such factors. Then there is what is called the design capacity, that is the capacity that can be sustained day after day, accounting for small irregularities in service and variations in passenger demand and arrival patterns. So, that is the design capacity. So, when somebody asks you how much is your system designed to carry, how many passengers is your public transportation system designed to carry. So, if you want to know the design capacity, then you have to again bring that reliability into factor, that can be sustained day after day, right. Maybe a capacity on one day you can carry a lot of people, you carried a lot of people, but the other day the next day you carry very few people. So, that will not be your design capacity. Your design capacity will be somewhere in between, most probably, that you can carry day over day. So, you never look at the highs and never look at the lows, but look at how much you can carry day after day. Maximum capacity, on the other hand, is the capacity that could be achieved if service was 100% reliable, passenger demand never varied, passengers filled every available space on every trip, etc. So, this is a very theoretical concept of maximum capacity, which in theory you can design and understand just to get an understanding of how many people your system can carry, but to reach that number it is very difficult. Most of the manuals and these all concepts are taken from a manual called the transit capacity and quality service manual, developed in the United States. All of them estimates design capacities rather than maximum capacity or person capacity. Then comes the vehicle capacity. So, now if you know that how many people can be carried as person capacity, you also may be wanting to know what is the vehicle capacity of a given transit route or a facility. Now, how is it defined? It is defined as the number of a maximum number of transit vehicles, buses, trains, vessels, etc., that can pass a given location during a given time period at a specified level of reliability. Again, there are different reliability levels, different types of time periods. All of that conditions put together, the maximum number of transit vehicles that can pass a given location, right. Now, we are talking about vehicles. So, from the operator's point of view, the operators have to know that what is the vehicle capacity of my system, right. If the operators know how much is the person capacity, then they can easily calculate the vehicle capacity as well. So, they have to match the person capacity to the vehicle capacity, right. This vehicle capacity can be given different names based on different modes. So, it can be called bus capacity if you are talking about a bus transportation, line capacity for a rail, a vessel capacity if it is a ferry, etc. And the desired levels of reliability play a significant role again, right. Vehicle capacity is maximized when a route or a line is operated at the minimum headway. Headway meaning the time that the one bus arrives, for example, and the time that the next bus arrives at the same point. So, that is the headway between the two consecutive buses. So, if that headway is minimum, that is when the vehicle capacity can be maximized. So, that the next transit vehicle is ready to arrive at a stop or when the vehicle pulls out of that bus stop. So, but however, we know that to maintain the proper headway, it is very difficult under operating conditions because of traffic congestion and so on and so forth, and also dwell times at the bus stations. So, we always want to minimize headway so that we can keep the vehicle capacities at a maximum. There is always unstable form of operation. See, we talked about dwell time exceeds the amount of time, and then the number of vehicles can that can be served, that should be served, will be less than what that can be served, right. So, when the reliability decreases, the vehicle capacity also decreases. The next concept to understand is the speed of a given transit route, right. Because people always make a trade off between whether to use their private vehicle and whether to use public transportation, and one of the factors they always take into consideration is the travel time or the speed by which they will be able to reach their destination, or what is the speed with which the vehicles public transportation vehicle will move on in the traffic stream. So, you have to understand the speed of a public transportation system or a vehicle. So, the speed of a transit service is the distance covered in a given amount of time, which can be also expressed as an inverse of the travel time rate, or the time required to travel a given distance, right. So, there are three main components of a transit speed. Running time, actually when the vehicle is running at a constant speed following the acceleration. So, it is accelerated, now it is running at a constant speed. The passenger service time, boarding and alighting time, that is also the vehicle is not moving, but it is loading and unloading passengers. So, that is also the time that has to be taken into account when you are calculating the transit speed. That is why we always want to minimize the dwell time at the stations, right. So, we have to load and unload very quickly. That is why you see that there are from one door you only allow people to board, and the other door you allow people to disembark, right. So, that is the case that speeds up or reduces the dwell time, and also delay, right. External factors that impede transit vehicles because of congestion. If you do not have your right of way, if you do not have exclusive right of way, then you are delayed by other kinds of things, signals, so on and so forth. So, all of these components play a crucial role in determining the transit speed. Again, we have already talked about all of this: dwell time, delay, running time, passenger service time. So, if you have if you have your own right of way, you have your own guideway, then your transit speed, you can maintain a good speed of your transit. Whereas, if you are operating on shared right of way, for example, the buses or trams, then your transit speed will be affected by those other modes as well. Then we have talked about reliability a whole lot. So, what is reliability? The reliability of a transit service can be defined differently from the passengers and operators perspective, right. We have been always talking about we always think about reliability in terms of passengers, where what is the passenger standpoint? Reliability is of arriving at one's destination on time and not having to wait too long at a stop or station for one's transit vehicle to arrive. So, reliability is that every day if I come here at 9 a.m., I will get the bus number 246, for example. So, that is reliable transit service from the point of view of a passenger or a user. From the point of view of a passenger, my service should be reliable. The bus should come at the same time every day, and it should take almost a similar time for me to reach my destination day after day, right. So, one day it takes me 45 minutes, the other day it takes me 25 minutes, that is not reliability. Then there is something seriously wrong in the operating conditions of the buses, right. So, it has to take me every day. Well, some day it takes me 31 minutes, whereas some day it takes me 29 minutes, that is fine. So, on average I can say that travel time on the public transportation is 30 minutes, and that is very reliable. So, that is what from a user's point of view reliability means, whereas from the operator standpoint, reliability impacts the schedule recovery component of a cycle time. So, what the operator is looking at is that the bus that has left one depot, it has to get back to that depot at a certain time. So, there is a cycle time for the bus, and if it maintains that cycle time and stops at all of the bus stops at the scheduled time, that is what is called reliability from the point of view of the operator. Otherwise, what happens is the operator cannot run all the scheduled number of buses on that route, and then will incur a lot of revenue losses for the day. Again, if you want to look at the different types of factors that affect reliability, they can be internal and external factors. And we have already looked at some of the external factors, which could be traffic signals, passenger variability, there is some road construction going on. Internal factors include if the vehicles are not maintained well, right? Service planning is not very well, the routes are too long or the routes are not well designed, scheduling is not achieved. So, all of these are internal to the bus route scheduling, whereas there are external factors, there may be the environment that comes into play as well. Then what we after knowing all these operational characteristics such as passenger capacity, vehicle capacity, transit speed, reliability, you have to know the characteristics of operations of public transit systems, right. There is time of the day demand variation. Always during the peak hours the demands are higher. So, you run public transport at a much lesser headway during those times, whereas during off peak times you keep the headways longer. So, that also allows your operational cost to be stabilized, to be maintained, right. There may be peak hour demand variation as well, right. There may be within the 4 hours 4 hours of peak period, there may be certain 15-minute there may be only 1 or 2 15-minute peak periods actually that happens. So, even within the peak time, so the peak hours may be from 8 a.m. to, for example, 8 a.m. to 10 a.m., but actually the peak period within the peak hours may be 8:45 to 9:15 or something like that. So, we have to pay extra attention to detail when it comes to these operational factors day to day in order to maximize your revenue and minimize your operating costs. How does passenger demand characteristics vary when it comes to transit services? They vary by gender, age, employment, and also one of the important factors is number of cars in the household, number of cars or private vehicles, in our case two wheelers as well. So, the minute you own a vehicle, your tendency to use a bus goes down. The other land use also plays an important role. It has been seen that if it is a CBD area and dense land use area, there you may need a higher number of the bus frequency needs to be higher, or the headway between the buses needs to be lower, whereas if the residential densities, if the suburban residential densities which are much spread out, there you can do by less number of buses per hour, for example. So, you have to when you are operating your services, when you are operating your bus service or any public transportation service in your system, in your city, you have to take care of all of these things. You have to keep in mind all of these things and just not design a bus service based on some other city's characteristics or some best practices from somewhere else. So, keep these in mind all the time. Let us look into some of the operating keys of transit service. Dwell time, travel time or dwell time is a very important factor, as we have already mentioned. There are 4 different components to a dwell time: passenger boarding and alighting volumes, fare payment method, vehicle size, type and size, and in vehicle circulation, right. All of these impact what is the dwell time at a station. For example, variations in passenger demand for a particular route over the course of 15 minutes, that may cause the dwell times to rise. So, if you just understand dwell time, which is the time that a bus or a public transport unit spends at a station to board and alight passengers, right. So, if the volumes of those boarding and alighting are very high, then the vehicle has to spend a longer amount of time sitting at that or idling at that station. It is not, the word idling may not be the right thing to use, but it is stationary. So, let us say it is stationary at a location. Fare payment methods, if you if you insist that everybody pays as they are boarding, then there will be almost a queue that is formed, and everybody pays the conductor or an automatic fare machine or whoever it is at boarding time, and so that may also increase the dwell time. However, if you have prepaid tickets that passengers already have with them and they just have to tap and go, so that reduces the dwell time, the queues will be less, and that is how fare payment method affects dwell time. Vehicle type and size, you can understand smaller vehicles, more number of people waiting to use those vehicles, dwell time goes up. Larger vehicles, two different doors or sometimes articulated buses with multiple doors allows you to reduce your dwell time. And in vehicle circulation, if there are multiple vehicles on that route that are working, that also helps reduce the dwell time, as people know that there will be a next bus coming in 2 minutes time. So, they would not want to keep the first bus waiting for a longer period of time. So, all of these factors help in the or impacts the dwell time, which in turn impacts the capacity of the public transportation system. Different types of guideways also has an impact on transit services. If you are working with, if your transit is operating under mixed traffic conditions versus grade separated conditions, this is something which is, although very expensive to build, but it gives you a lot of gives you reliable services and gives you capacity that is much more higher than if you are operating under mixed traffic conditions. The other two conditions are somewhere in between these two extremes. Also, the traffic environment and the interaction impact. I mean, if you are in mixed traffic, you are interacting with different types of bicyclists, pedestrians, non-motorized vehicles as well as motorized vehicles. Whereas, if you are on a transit guideway or even just something that is separating your right of way from theirs, it may not be, it may be still at grade, but it is just separating your right of way from the other traffic. Then it helps you not only maintain speed, helps higher capacity, so on and so forth. The next type of environment that impacts transit services are the station and the station or the stop characteristics. Sometimes you do not have a station meaning at least you have a platform, whereas stops meaning just you have a sign saying this is a bus stop. So, these types also impact your transit services. Vehicle platform interface, if there is a station and there is a difference between the height of the vehicle that you want to alight and board or disembark and your station surface, then that creates a problem. Different types of vehicle characteristics, the number of doors available, we have already talked about the number of doors, their widths also influence the capacity or the dwell time. Fare collection we have already looked at, and stop spacing also. Like I said, if the two stops are too close to each other, then the number of people that may be accessing your public transportation system may be very good, versus if the two stops are too far from each other, then there may be, you may be losing out on all the people that are living in this kind of an area. They may not use your public transportation system at all. So, stop spacing is also something that is very crucial to transit capacity as well as speed. So, that brings us to the end of this lecture series. In this lecture, what we have told you quickly is about the basic aspects or a little bit more than the basic aspects, but the aspects on operational characteristics of transit, looking at transit capacity, speed and reliability. Reliability is something that you have to keep in mind, both from the user's point of view as well as from the operator's point of view. When you are talking about capacity, you have to look at person capacity, vehicle capacity as well as station capacity. So, all of these elements, once you are aware of all of them, you have to consider the different factors that impact these aspects of transit service. And once you know, one of the most important factors is the dwell time, and we have given you an understanding of how dwell time impacts these capacities. So, hopefully, you are now well equipped to move forward into further understanding of how our transit operations happen. Thank you for your attention.